Hey, this is Mr. N going over Precalculus quiz number, those numbers were wrong. Should be quiz number 9, 4-1 to 4-2, January 23rd, 2019. Question 1 to 6. For questions 1 to 6, state the trig ratio, leave as a fraction. I only gave you two sides of a right triangle. Hopefully you recognize that. Well, if I have two sides of a right triangle, I can just use a third side using the Pythagorean Theorem. So I call this the C because that's the hypotenuse, because it's always across the right angle, and then A and B does not matter. C squared equals A squared plus B squared is the Pythagorean theorem. Basically, if you have two sides of a right triangle, it helps you find the third side. 41 squared is 1681, and 9 squared is 81. Subtract 81, you get 1600 equals A squared, and then A equals 40. And then if you got confused with the two different Greek letters here, this is alpha. What I did is I just put alpha here, and then you label your triangles based off that. So you have the opposite, you have the hypotenuse, and the third side is called the adjacent, which means it's next to this angle. You have theta here, and then based off that triangle, you have the opposite. This is the hypotenuse, and you have the adjacent. So basically, the hypotenuse doesn't change, but the opposite and adjacents do based on where that given angle is. And then here I have sine of theta, cosine of theta, tangent of theta. That would be SOHCA TOA. So sine of theta would be the opposite over the hypotenuse, 9/41. It says leave as a fraction, so if you put in decimal, incorrect. If you found the angle itself, incorrect. If you put in x because you were missing a side, that's incorrect. You had to solve for the third side. Cosine is the adjacent over the hypotenuse, 40/41. Tangent, so the opposite of the adjacent, that would be 9/40. Tangent of theta should be, opposite over the adjacent, 9/40. Sine of alpha is the opposite over the hypotenuse, which is 40/41. Cosine of alpha, so I'm not looking at cosine over here, I'm looking at cosine here. So this would be the adjacent over the hypotenuse, and then tangent of alpha is the opposite of adjacent, which is 40/9. So here's a student who couldn't recognize that you should have used a Pythagorean theorem to solve for the third side. Another student who didn't know to solve for the third side using Pythagorean theorem. A little bit hard to see, but here's a student who did use it. You can see the Pythagorean theorem there, and they got 40. They got 6 out of 6 correct. Question number 7, diagram below shows the triangle UPC. You have the sides 18, 17, 15. Which ratio represents the sine of angle U? So angle U is your starting point, and that's why I circled it. So if you're struggling with labeling these, circle your given angle, that's your starting point. So I have opposite, I have the hypotenuse across the right angle, and then you have the adjacent, which is next to the angle, and then sine is the opposite over the hypotenuse, so that would give you 15/17. The student had a good strategy where they didn't like the orientation of the triangle, and they just recopied it, and they labeled it correctly and did the same thing and still got A, which is correct. Question number 8 says, what is the value of secant of 70 degrees to the nearest thousandth? 70 degrees is not on, or secant is not on your calculator, so you're going to have to do a secant of 70 degrees. Well, what I did is I wrote that above secant of alpha. And then here you have the reciprocal identity. Secant of alpha equals 1/cosine of alpha, and then alpha is 70 degrees, so I put into my calculator 70 cosine of 70, and I get this decimal, and you can do 1 divided by 0.3420. And that gives you 2.9238, which is the letter D is your correct answer. So this is interesting. The student, I don't know if they were trying to convert this. They thought from degrees to radians, so that would have been incorrect. All right, this student made a classic mistake, got the answer wrong. Reciprocal identity is correct. They got all of this correct. 1/cosine of 70. But what they did is they just put in cosine of 70 and got 0.34, and then that's why I circled A. So they have to do 1 divided by that. That's why we do calculator ready equations, so you can kind of see like you're not really using your calculator till the very end. All right, question number 9. What is 240 degrees in radians? We have this awesome proportions. Part over whole equals part over whole. Remember, angles can be measured in both in degrees of radians, so degrees over 360 equals radians over 2 pi. They give you 240 degrees, put it there. Find out the greatest common factor, which is negative 2 times 120 equals negative 240. 360 is 3 times 120. And remember, if you did something like broke it down by tens, then you would have gotten like negative 24 over 36. And just keep dividing by 2 if they're both evens or multiples of 3s or 5s or something like that. So basically, I have negative 2/3 equals radians over 2 pi. Here you're going to cross multiply. So the negative, I decided just to leave it in the numerator. So negative 2 times 2 pi gives you negative 4 pi. 3 times radian gives you 3 radians. And then to solve for radians, I'm going to divide it by 3 on both sides. Radians equals negative 4 pi over 3, which is your letter choice D. Like this, student simplify negative 240 over 360 to be 4/6. And then recognize that goes down to negative 2/3. Yeah, still got the problem right. Question number 10, multiple choice. Convert the angle in degrees to radians. Express the answer as a multiple of pi. So I'm given 36 degrees. Then want my answer in terms of pi, which means you should have pi in there. So again, here is my awesome proportion. Degrees over 360 equals radians over 2 pi. Put in degrees there, 360 over 360 degrees. I'm going to reduce that, so my factors are 36 times 1 and 36 over times 10. I cancel my 36's, and so I get 1 over 10 equals radians over 2 pi. Cross multiply, you get 10 radians equals 2 pi. Divided by 10, and then you reduce this. That's 2 times pi, and this is 2 times 5. Cancel your 2's, and your radians is equal to pi over 5, which is A. Here's a correct work by a student. So the student has a correct proportions. Too bad it wasn't a free response question. And then 2 pi times 36, correct, divided both sides by 360. So that's where I think the student got lost here. They should have put 360 over here, right? Division, property of equality. If you divide both sides by division, if you divide this side by 360, you have to divide this side by 360. Question number 11, when do you use the inverse button on your calculator? The answer is you only use the inverse to find the angle measure. All right, so I'm going to use student work. I made a mistake of mine. The answer for number 12 is D. So if you got D correct, I will be changing that, looking at all these PDF files and giving you 2 points for correct for D. If you marked A, somehow I made a mistake, you were marked right, and now you'll get a -2. So let's do the problem. In the right triangle shown below, the length of AB is 8 units. Angle A measures 60 degrees. And it tells you that each of the trig functions, sine of 60, cosine of 60, and tangent of 60, approximately how many units long is BC to the nearest 100th of a unit. So the question feels kind of weird because why would they give you this information here? This problem was meant to be a non-calculator problem, meaning you were meant to do the problem without a calculator. So if I start at my given angle, 60 degrees, and you use the, you're trying to find BC, the student called it X, which is correct, and then the opposite of the hypotenuse, that gives you sine. Sine of 60 equals X over 8. Cross multiply, 1 times X is X, sine of 60 times 8. If you put in your calculator 8 times sine of 60, or sine of 60 is 0.866, when you multiply those, you'll get X equals 6.93. Let me show you an alternative way to get the problem as well correct, and that's just using your special right triangles. You have a 60-degree angle, so that tells me that if this is 60, that's 90, this has to be 30. So if you drew a equilateral triangle on this side, then you'll get 60, this is 30, so that angle together would be 60, and then that would be a 60, right? So this would be 8, this side would be 8, and this side would be 8. If this side is 8, then we talked about how this is a perpendicular bisector, so this would be 4 and 4. So if you have 8 and 4, you can either use a Pythagorean Theorem to get this side to be 4 radical 3, or the properties of a special right triangle is that the hypotenuse is 2 times the short leg. This would be the short leg, so it would just kind of be like, I don't know what you call it, maybe 2 times y. Y represents the short leg, and then the cross the 60 would be y times radical 3. So I knew the answer would be 4 radical 3, and then 4 times radical 3 gives you 6.93. All right, the student added the two angles together and got 150. Recognize that triangle should be 180. I think that's a 30 because they wrote 30 here. Hopefully, I recognize 30 is not a side, it's an angle. I don't know if they got stuck and then they just put that answer. Not quite sure. Student started at 60, labeled it correctly opposite x in the hypotenuse. They wrote sine of 40. Hopefully it would fit sine of 60 as your starting point. So that's why they are incorrect. Question number 13, which equation shows a correct trig ratio for angle A in the triangle below? Angle A is here, and so I'll just walk through why the rest of these are wrong. Tangent of A is opposite of the adjacent, so it would be 8 over 15, but this one has 8 over 17, so that's wrong. So again, label your triangle opposite, hypotenuse, and the third side is called the adjacent. This one says tangent A is 5/8. If you go across the opposite adjacent, this should be 8 over 15. So another way of thinking about it is, why do they get 8 over 17? This should really be sine of A equals 8 over 17. That's the opposite of hypotenuse. What is 5/8? None of these. What is sine of A? Sine of A should be the 8 over 17. So 15 over 17 is the cosine. Cosine of A is 15 over 17. And then the correct answer is this one, because it tells you which one is correct, and this is the only one that's correct. So label your triangle. Yay, the student labeled the triangle, got the problem correct. All right, question number 14, which equation is the reciprocal identity? The reciprocal identity of secant is 1 over cosine. That's just straight from your formula sheet. Question number 15, what is the length of the arc that subtends the central angle of 150 degrees in the unit circle? If we have not talked about it already, and I told you guys the unit circle, it means 1 unit. That means your radius is 1. Subtends just means it extends on the arc, which I don't have a picture. So your formula is arc length equal over 2 pi r equals degrees over 360. Part over whole equals part over whole. So the arc length, which we don't know, we're going to call x. 2 pi r is your circumference, so the radius there is going to be 1. So that's just going to become 2 pi. So x over 2 pi. 150 over, let's look up here. 150 is your given angle, central angle in your formula. So just reduce 150 over 360. So 5 times 30 and 12 times 30. So my greatest common factor is 30. So I get 5/12. So there I'm just going to cross multiply 5 times 2 pi r and then x times 12. And then divide 12 on both sides. And then we already said radius is 1, so that's just going to disappear, and then you're going to have 2 times 5, which is 10 pi over 12, which reduces to 5 pi over 6. So your correct answer is A. All right, so the student has a drawing here, which is helpful. The length of the arc, so we're trying to find this arc right here. And the central angle is 150 degrees. Well, it's an obtuse, but we'll take this for right now. And then you have the radius 1, which is correct. And then what happened here is they have part over whole, 150 over 360. What they're missing here is arc length over 2 pi r. So I don't know if they didn't have that on their formula sheet, which you're allowed to use formula sheets. Just use that information there. Number 16 says, given an angle, find the trig ratio round to the nearest 10,000ths. So to review for 10,000ths, I wrote these dashes here. 1 decimal place to the right is called the tenths, and this is the hundredths. Third one is the thousandths, and then the fourth one is 10,000ths. To round to the fourth one, you're going to have to look at the 5th number. So if you put in your calculator in degree mode, sine of 42 degrees, you're going to get these 5 decimal places, and the reason why I showed that to you is to help you round. So if this number is 0, 1, 2, 3, or 4, you're going to keep this number, which that is the case, and that's why the answer is 0.6691. If you have that, then you got 1 point. And I purposely chose the same angle, so cosecant is not on your calculator. So cosecant alpha equals 1 over sine alpha. That's just reciprocal identity. And then alpha is 42 degrees. So if you put in your calculator, just be careful, use your parentheses, parentheses 1, close the parentheses, divided by parentheses sine of 42, close parentheses. You'll get 1 over, you'll get an answer of 1.4945, or I wrote all the decimals out here. Another way you do the problem is just take your sine of 42 degrees, which you just found on the last problem, and do 1 divided by that, and you'll get this number. So I'm running to basically the 4th decimal spot. This number is 5, 6, 7, 8, or 9. So that means this number is going to round up, which I did. I moved it to a 5. Again, these are just 1 point each. Here is the student round to the tenths. These are round to the 10,000ths. Here I gave the student 1 point for the correct problem over here. Over here, they put into their, I don't know what happened. So if this was a free response question, that would have given partial credit, but it wasn't. Question number 17 says, given the trig ratio, find the angle measure round to the nearest whole degree. So here I have sine of an angle equals 2 over 11. So the sides are 2 over 11, and then we're missing this angle. So you're going to circle these two, and then you put these arrows. That's called the inverse. So you have to put that little sign right here. So the inverse of sine over 2 over 19 equals theta. So if you put that into your calculator, you'll get 10.4756, and it tells you round to the nearest whole degree. So that's less than, this number is less than 0, 1, 2, 3, or 4. That number is going to round. You're going to keep that number. So my whole number is, the answer is 10 degrees. Because it tells you that it's measured in whole degrees, that if you put a 10, you're assuming that it is degrees. So I didn't mark you wrong if you didn't have that, but only because that problem says so. All the other problems, you should have had that. Over here I have cosine of theta equals 0.68, and I'm just going to again take the inverse, circle them, practice that in class, draw your arrows, and then you get the inverse of cosine. So remember, when you're doing the switching, you're going to have that inverse symbol. Inverse of cosine of 0.68 equals theta. These are all the decimal places, so this is less than 5, so this number is going to stay. 47 degrees is your correct answer. Look at that. Got them arrows. Yeah, it would have been nice to have a calculator ready equation just for practice. Oh, look at that one. Calculator ready equation. Awesome. Let's see what this student did. I think they just typed in sine of 2 divided by 11. Yeah, and then they moved the decimal place 3 spots. 1, 2, 3. Yeah. Yeah, wrong. Remember, if you don't have an angle here, you can't put that into your calculator, so you're going to have to take the inverse. Remember, in this problem, we're finding basically an angle, and it tells you the angle measure. Question number 18, solve for x round to the nearest 10th. So x is an angle, which means you're going to have to take the inverse. So circle it. This is your starting point, and you're going across this angle. This is across, means opposite side. Across the right angle is called the hypotenuse, and then the last one, always go in that order, opposite hypotenuse, then adjacent. I have here, the third side is called the adjacent. So in SOHCAHTOA, you write that out. I'm crossing off the hypotenuse because I don't have a variable or a number here. So I have adjacent and opposite, so you can cross off all of those that have hypotenuse. So not sine, not cosine. So the answer is TOA, which is tangent. Tangent of x equals opposite of adjacent. The opposite side is 18, and the adjacent side is 4. If you pick the correct trig ratio and the rest of your problem's wrong, then I give you 2 points. I'm going to circle those and draw the arrows to show that you're going to switch them. Switching means the inverse. So the inverse of the two sides is There's your calculator ready equation. So you got 3 points. If you have a calculator ready equation, inverse of tangent of 18 over 4 equals x. And then it tells you round to the nearest tenth. Your answer is x is approximately 77.5 degrees. So yes, I decided, we talked about in class if you don't have that, although it does have a degree symbol, we did talk about having that. Correct problem, looks good. This problem, no calculator ready equation. Again, when the problems get more difficult, and also no degree symbol. All right, let's go over this problem. Zoom out a little bit. Solve for x round to the nearest tenth. So again, start with that angle, circle it, label your sides, go in this order, opposite, cross the right angle, hypotenuse, and then the third side adjacent. So there's nothing here on the opposite side, so you can cross off all the O's. You have ka, which is cosine. Cosine of the angle, so if you're still struggling, you're always write a trig ratio and then an angle. And then over here you have a side over a side. So cosine of this angle, so cosine of 50 degrees equals the adjacent over the hypotenuse, which is x over 28. Again, if you pick the right trig ratio and the rest of it's wrong, I'll give you 2 points. So you're going to make this over 1. Here, you're going to cross multiply. The reason why I'm cross multiplying is you're solving for x. Or another way to think about it is you're just multiplying both sides by 28 on this problem. My calculator ready equation, CRE, calculator ready equation, x equals 28 times cosine of 50. And you put into your calculators, your answer is approximately 18. I think your calculator came out to like 17.9. So if you got 3 points if you wrote like 17.9 or if you wrote just 18. I do want to round to the nearest tenths. This student labeled it correctly and then didn't realize you're solving for a side. So they thought, well, if I'm solving for a side, can I use Pythagorean Theorem? I think they stopped as they realized they didn't have 2 given sides to find the third side. Look at this one, looks good. Dope, that's the 10th. Here's an interesting thing. The student, I see why. They mislabeled their triangle. They thought this was the adjacent side. So, yep, it was a triangle. Now, question number 20. Find the values of x and y. Write your answers in simplest radical form. A couple of ways that I solved this problem. The first one I did is I just used trig ratios. So if I have y and then x and then 12 radical 3, I have a 30. This angle is going to be a 60 because in a triangle you have triangle sum theorem, blank plus blank plus blank equals 180. Subtract the 90, so these have to be complementary. So here I just took my triangle, redrew it, so I have the opposite over the hypotenuse. That would be sine. Sine of 30 equals y over 12 radical 3. Here, if you cross multiply by making this fraction, put it over 1, you'll get my calculator ready equation. Y equals sine of 30 times 12 radical 3. Now, if you put that in your calculator, over here it says, write your answers in simplest radical form. Radical form just means you want radicals. So hopefully you put in your calculator and recognize the sine of 30 is just 0.5 or 1/2. 0.5 times 12 is 6 radical 3. So that was the answer I was looking for y. For x, you're doing the same thing. You have the adjacent over the hypotenuse. This gives us cosine. Cosine of 30 degrees equals x over 12 radical 3. Cosine of 30, if you put into your calculator, the answer is blah, 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 blah. Uh, 0.866. And if you multiply that by 12 radical 3, you get the answer of 18. So to get both those answers correct, you have to have both of those with your work. If you got one of those right, then I give you 2 points. If you had issues, like maybe you rounded to decimals, then I give you 3, assuming both of those were correct with decimals. No way is solving the problem is, again, recognizing that this is a 30 and this is a 90. If that's a 60, then you have a 30, 69. It's a special right triangle. Then you can just make an equilateral triangle like I did. And when you do that, that's a 60. This is a 30 and 30, so that's also a 60. So equilateral means all the sides are the same and all of the angles are the same. So if this is 12 radical 3, this side's also going to be 12 radical 3. And then this whole length here is going to be 12 radical 3. But if you're going to break that apart, that would be essentially 12 divided by 2 is 6. So 6 radical 3 is this length on this side, because 6 radical 3 plus 6 radical 3 would give us 12 radical 3. And then what did I do with that? I used the, if I knew this side was, y was 6 radical 3, then I can use the Pythagorean theorem. So I call this side c, this a, and this side b. Substitute 12 radical 3 squared equals 6 radical 3 squared plus x squared. So 12 radical 3 squared is essentially 12 radical 3 times 12 radical 3, or 12 times 12, which gives you the 144. Radical 3 times radical 3 is radical 9, which is square root of 9 is 3. And 6 squared is 36, and then radical 3 squared is 3. You multiply those two, you get 108. Subtract 108 from that. 144 times 3 is 432. Subtract, and you get 324. And if you take square root, then you'll get 18. Let's take a look at some student work. Dope. Didn't try it. Could have gotten 1 point. This student I gave a 3 out of 4 because this decimal is correct, but I highlighted that they didn't give me a simplest radical form. Saying these students were all correct with this equations, and then right here, they got to pick up on that. I still got to keep that radical sign. Question number 21. A 40-foot ladder is leaning against a building. So put the ladder there, and it's 40 feet. The foot of the ladder, there's the foot, the bottom, is 32 feet from the building. The foot of the ladders is 32 feet from the building. Find the angle that the ladder makes with the building. So I cannot say that if I draw my picture here, I don't want the third side, so I'm not using Pythagorean theorem. I crossed off this picture because this is a common picture, because this would make sense if you said find the angle that the ladder makes with the ground, but it doesn't say the ground, it says the building. So this why if you did cosine and from here, then I gave you only 1 point. To get your 4 points, I give you 2 points for a correctly drawn picture that was 32, right angle, hypotenuse, ladder 40, and then the X was up here, ladder to the building, because it says find the angle of the ladder it makes with the building. So from here, this would be your opposite, and this would be your hypotenuse. Sine of X equals opposite of the hypotenuse. Sine of X equals 32 over 40, and then here, circling those, draw your arrows. You're taking the inverse calculator equation. So you're getting 3 out of 4 points, even if you have the calculator equation, and then this is wrong. And then it says, I told you guys round to the nearest 10th. Your answer is 53.1 degrees. Students correct. I just want to show you what would happen if they did not have this correct answer and they left it like this with no calculator equation. If that was wrong, then you're at a 3. No calculator equation, going down to a 2. So having that calculator equation, even though it's got full credit, definitely show your work. Don't be lazy. Wow, look at this one. I just wanted to show you. Student found the answer, and then they used it to double check their answer to show that you get 32 feet. That's great. Here's a 1-pointer. Again, they put the X at the ground. It says with the building. All right, this student, 40-foot ladder, correct. Does not say the building is 32 feet. And then over here, remember, we're using trig, so you're going to form a right triangle, so that can't be an X there. It's going to be a box, which is 90. This student has multiple X's here. Remember, ladder can't, where's the building? So pictures are helpful. The ladder's got to be leaning, 2-dimensional. Maybe this is kind of like forward-facing perspective. this student thought we were finding a side, so they used the Pythagorean Theorem. And then they went ahead and said, well, 51.22, the angle, so they went from a side to an angle. So that would be incorrect. So I'm going to show this last one. Correct picture, calculate an equation, and degrees, come on, degrees. That side was at 23. Hopefully it was helpful for your quiz. Good luck.